Hello everyone, John from Vulgar Kitten Studios, and now we're going to be going ahead and continuing on with our data saver using MySQL. And in this video we're actually going to create our characters or make our GUI actually function as we want it to. So the first thing that I need to do is just open up the main menu scene, and I'm actually going to play the game just to see how this looks. And we have our buttons and everything, so that all looks okay. One thing I did notice is we'll probably actually need to go ahead and change our anchor position. So I'm going to do that now before we get too deep into this. And just because it's probably a little too low, so I'm going to raise that up just a little bit. And to test it, I'm going to take a 3D object and we'll use a capsule, and I'll put that on the character anchor and reset it, and we'll play the game. And yes, okay, so that is going to show up nicely. So I'll go ahead and delete this off, and we'll check our character creator, and we do have the character creator script on here. So let's just go ahead and edit that script. So we'll open it up, and you'll probably be using MonoDevelop. However, I do recommend Visual Studios if you can get a hold of it. So that's what I'll be using. And now we'll actually start this out. So the first thing that we need to do is get a public reference, public transform reference to our character anchor, like that. And I'm going to go ahead and hook that up now. So come back in here, and matter of fact, we'll need to make sure that I go and format my document. And I'm pretty sure that that's because of the script template that I created using Unix style line endings, but that's neither here nor there. I'll stop wasting your time. And I'm going to go ahead and take the character anchor and plop that right there in the reference on the script. So we'll go back into Visual Studio now, and we'll finish this out. So I'll come into my private fields and properties and make a private game object, and this is going to be called character object, like that. And I'm also going to get a private reference to our server that we just created, which is not master server. In order to use that class, we will need to use our data manager namespace. And also we'll probably be making use of the JSON class in here as well. So I'm just going to go ahead and put using boom lagoon .json like that, so we can make use of the JSON object class. Okay, so now we'll get the reference to our server class, and I'm going to call that server, and that's going to be equal to a new server. Be sure that you instantiate it, or else nothing will work, so you do need to do that. And now we'll go into our start method. However, we're not going to be returning type void. We're going to be returning type enumerator, because this is going to be a coroutine. And the reason that we want to do this is because sometimes communication with our server can be a little bit slow, especially if you're using an external database from where your website or your game is actually hosted. So if you have a web host and you're using horizontal scaling methodologies where you're using a separate database server, then you'll definitely want to use coroutines so you can get this working properly, or else you're going to get lag and it's just going to be bad news. So what we're going to do is we're going to yield return, and then we'll start coroutine. And the coroutine that we want to start is going to be server.get data. And remember, the data that we want to get is from an ID of a user, which, come to think about it, we don't actually have any data in there. So we'll go ahead and construct this method. We want to start the coroutine, get the data for the ID of the user 1, and we'll just go ahead and go into phpMyAdmin and actually create that data. So we'll come into phpMyAdmin, and I'll probably need to log in again. So let this go here. Yep. So I'm going to log in as root, and we'll come into Unity JSON, and actually the users table is actually kind of useless in this example. I just wanted to show you how the cross-referencing system should work. So you would have a users table that has, your user with their username, email, password, etc., etc. And each one of these users would have a unique ID field, which is this auto incrementing value here. So every time a user is created, if the last ID was 1, then the next one that's created is going to be 2, 3, 4, so on and so forth. So what I'll do is I'll just create a user and call him John, and set his created at to today, and updated at to today, and just go ahead and click go. And now we'll see how the cross-reference system will work. So we'll come into the user data field and we'll insert a record into here. And we won't touch the ID because this is going to be the primary key auto incrementing value that is a unique identifier for this specific record. But we will set the user ID. And what we'll set it to is 1 because the ID field of our user table or our entry in the user table is 1. We won't put anything in the data for now, but we will set the created at and updated at to today. And we'll examine these closely. So again, we'll click on user data, and we see the user ID is 1, and this is corresponding to the user's actual ID here. And that's the reason that we do that. So we'll come back into Visual Studio, or MonoDevelop, whatever you're using, and we'll say if, and then we'll check the server.data, which is that JSON value, and we'll check if that contains a key. And the key we're going to check for is going to be character. And you can call this whatever you like. I'm just calling mine character because it makes sense. And in here, we're actually going to instantiate our characters and everything. So we'll also want to put in an else clause, because if there is a character already in the database, then we want to instantiate that character. Otherwise, we want to instantiate a default character. So we'll do this by using the GameObject class and then call this saved object, and we'll set that equal to resources dot load, and the resource that we want to load is going to be the server dot data dot get object, and the object that we want to get is character. So if the character has been returned, we know we have this object in here. And then we'll say get string, and the key under character that we're going to be checking for the object to load, I'm going to call it body. So we'll get that, and we'll also want to cast this as a game object because we're using the resources.load method. It wants us to cast it as a game object if it is a game object. So we'll do it that way. And also the reason that we're storing this in a variable is because whenever we instantiate anything, it's going to by default come with the word clone tacked onto it, and we really don't want that. So we're going to use this method to actually remove that. And so next, what I want to do is I actually want to abstract the ability to do the instantiation process. So I'm going to come down into my public, or not my public, but my custom methods, and I'm going to create a new public void and call this instantiate character, and this is going to accept a type of game object, and I'll call that guy character, like so. And in here we'll first of all check if the character object is not equal to null. So if there's already been a character object set, then what we want to do is we actually want to destroy that object, just so that we can actually swap out models and stuff like that. And this might not be the best way to go about doing things, because the more you instantiate objects, the more you kick in the garbage collector for C#. So really what you would want to do for maximum efficiency is instantiate all of your objects at runtime and then just reuse those. However, that's a little bit outside of the scope of this tutorial, so just random instantiation, or I guess linear instantiation would be a better term for it, is a little bit faster to do. So that's why I've opted to go with this this way of doing it. So now we'll make a game object, and I'm just going to call it obj, and we'll set that equal to the character. And then we'll set the character object equal to, and then we'll cast this as a game object. and then we'll instantiate the obj, and let's see, I actually want to use the character anchor dot position for the position at which we want to instantiate it, and the character anchor dot rotation for its rotation. And of course we could have used quaternion identity here, that would have been fine too, but the reason that we put an anchor in there is just in case we want to do anything with rotations and such. So now we have that ability, if we so desire, to implement it. Now we'll also set the character object dot name equal to the obj dot name right here. So that way we can get rid of the clone suffix from our instantiated objects. Also, we're probably going to actually have character controllers and a player motor script and everything on those objects as well. So every time we instantiate them, we don't want them to fall into oblivion. So we'll go ahead and disable those. So we'll get the character controller. I'm going to call that CC for character controller. And I'm going to say character object dot get component, the character controller component, and I'll say CC dot enabled is equal to false. Also, we'll want to do that with the player motor, so I'm going to get the player motor, call it PM, and that is going to be character object dot get component player motor, and just set the PM dot enabled equal to false. That way. Alright, so now that we've abstracted the ability to do the instantiation for us, we can reuse that method anywhere in our code. So we're going to say instantiate character in where we're checking if the character key exists. We're going to instantiate the character saved object, and that should be all that we need to do right there. We'll also want to do the same thing but with a default object if the character isn't there. So I'm going to call this game object new object, just because we can't instantiate a game object with the same name 2 times in the same method. So I'm going to say game object new object is equal to resources dot load, and I'm just going to explicitly call a default object, which we have one called cube, and we'll of course need to cast that as a game object as well, so we don't break the resources class. And now that we have that, we'll go ahead and instantiate the character. We'll instantiate the character new object, like so. And now we'll come outside of our check, and okay, so that should be everything. Yep. Actually, no. What I've just realized is we are using the instantiate character method here. So yeah, we don't need to do anything else in here. And let's just go back into Unity, make sure we don't have any errors. Okay. And we'll come back into Visual Studio now and finish this out. So what we're going to need to do is abstract the ability to change the color of an object as well. So what I'm going to do is I'm going to first of all get rid of this update method, because we're not going to need that. So I'm just going to get rid of that right out the gate, and I'm going to create another public void and call this change character color, and we'll accept a string, and I'm just going to call that C for color, and then we'll use a switch statement, and we'll switch on the value of C, and we'll say in case that string is red. Also we'll need one for yellow, and one for blue. And in case it's red, we'll set the character object dot renderer dot material dot color equal to color server.red. And it's the same thing for the other colors as well. There we go. And now let's see. We'll also need to bake in the ability to save that into the database, and we'll want to do that in this script. There's no reason not to. So I'll just put this below the color method here, and I'll make a public void, and we'll call this save character. And we don't need any parameters. So what we'll do is we'll create a JSON object and call this character obj, and that is going to be equal to a new JSON object, and we'll need another JSON object, and this is going to be equal to character color. And just for tidiness, I'm going to line those up like that, and Visual Studios is going to yell at me for doing so. Okay, so now we have those. We'll just go ahead and set the character color equal to server.makeColor, and the color that we want to create is going to be out of our character object's current color. So we'll get the character object.renderer.material.color, and that will convert that color into a JSON object. And so now we'll actually want to start constructing our object. So we'll say character obj dot add, and we want to add the body piece, and we'll say character object dot name. And this is the primary reason that we want to take that clone off of the game object, just so that we can actually access it by name through the resources class or through asset bundles if you have that ability using Pro. And so we'll say character object dot add, and we'll add a color parameter, and we'll use the character color value in order to do that. Alright, and so now we'll, since we've actually created this character object, what we want to do is be able to nest that under a value called character. So now what we'll do is we'll use server.data.add, and then we'll add a value to the base object called character, and then we'll just pass in the character object JSON object as its value right there. Lastly, we'll need to start the coroutine to actually save, and we'll use the server.saveData, pass in the first number for our user ID, and server.data for the data that we actually want to save. And lastly, we actually want to give the ability for the player to click the play game button and then take us to the correct scene. So we'll make another public void and call this play game, which isn't going to return anything. And in here we just have this standard application change logic. So we'll say server.data.contains key, just to do a little bit of error checking to make sure that the user has saved a character. We'll check if the character key exists, and we'll get our syntax right. Else, you would probably want to display a graphic or something to the user at this point in time, but I'm just going to use the debug.log method or the print method, whichever one you want to use, and we'll just tell the user that you must make a character first. And if they have already made a character, then we'll just use the application.loadLevel, and we'll just load the level game like so. Alright, so now that we have all our methods, let's actually start hooking these up into buttons. So we'll come into our character control or character creator menu, and for the cube we'll need to actually instantiate that character. And so what we'll do is come down to our onClick function, and then we'll add a callback, and we'll use the character creator object, which is also the canvas, and drag that on to the object, and then we'll check the functions, grab our character creator, and then we'll want to instantiate a character. This accepts the type of parameter game object, so we'll come into our resources folder, and this is cube, so we'll just match that up and put cube in there. Now we'll come into capsule and just do the same exact thing. Throw on our callback, use our method, and drop in our capsule prefab. Cylinder, let's do it again. Character creator, and instantiate a character, and drop in our cylinder prefab. Now we had that state machine using the switch statement for our colors, so we'll just actually need to add a callback in here as well. And then now we'll use the change character color, and this is red, so we used the lowercase red for the case for that. Come into yellow and do the same thing. Change character color, lowercase yellow, and blue. Come into here, change character color, and lowercase blue. Now we actually need to hook up the save character, so we'll just get our callback again. And this method we only actually have to call it, so we'll just call save character. Same way with the play game, so we'll just add in our callback and come into our function, character creator, play game. And I'm just going to go ahead and Control S to save for good measure. We'll go ahead and play. And there we go. We see we get this default object. So now let's actually test our saving character data. So we'll make sure that we open up our database here. And I'm going to open this up. We can see we don't have any data in here. Also, what I want to do is I want to go to game data, get data, and then pass in the ID of 1. Alright, so we can see that we don't have any errors. This is giving us a blank screen. Let's come back in here and let's change to a capsule. Change its color to yellow and click Save Character. Now we should be able to come back into here and we actually do see our data, so we know our data is being saved. Let's go ahead and check that in here just for good measure, and we'll examine this this object here. So again, like I said, we have a top level object called character. So these first two color braces can go here, and we can see that this character now actually has its own object values. So the body object, or the body key, has the value of capsule, which is the object that we selected. The color key has the value of an object which holds the RGBA or RGBA values of the color. Alright, so hopefully you can see how the JSON string is constructed and see how its elegance is really advantageous for saving complex or more complex data types. Alright, so that is about it for saving the data. Now all we need to do is worry about loading the data, and we'll do that in our next part. But before we go, let's just go ahead and stop the game, and we'll go ahead and play, make sure that we do actually get our data loaded. And we get everything except for the color, so let's look at that real quick. So I'm going to come back into here, and let's see. Getting a little lag on my mouse there. So we'll come up into our start method, and we've instantiated the character. The only thing that we haven't done is set our character object.renderer.material.color to be equal to the actual color. So we'll say server.get get color, and the color that we want to get is from the object character, and its key is known as color. So let me just make sure I'm not playing, and I'm not, so let me go ahead and save this, and we'll check to see if that actually does load our color. So go ahead and play, and it does. Alright, so like I said, this video is getting kind of long. That does it for saving and creating our character. So thank you for watching, and I'll see you in the next one.